Good day and welcome to the Math Salon. If you are new to the Math Salon is a YouTube channel in which we try to help students, everyone indeed who is interested in mathematics, and I would say everyone, because one way or the other, you get to use mathematics in your daily life, sometimes unconsciously. The idea within the Math Salon is that we really try to go from the basics, increase to the more complex situations. So we also try to make our students and our audience understand that mathematics is actually intended to make their lives easy, not the other way around. So today we'll be looking at permutations and combinations. These come very often in exams and also in your daily life. For example, if you dress to go to work, you would like to make sure that from time to time you look different. To do that, you have to change maybe your shirt, your trouser, or shoes. You can actually sit down and make a calculation to minimize the amount of dress and shoes you buy if you want to change your dressing code every day. This requires some simple thinking and not more than that. It could also just be rearranging a house. You're fed up after 1 or 2 years and you want to change your sitting arrangement, you want to change where your TV is placed. All these require things that have to do with the idea of permutations and combinations. They come under the topic counting. Of course, counting is different at this level. It's not like just 1, 2, 3, 4. But the idea of counting is rearranging and counting the number of possible arrangements you can make. That's a bit what we'll be looking at today. We will start from the basics. So I will start with something very simple. So let's say we have 3 letters, A, B, and C. We will start with what we call counting without repetition. So you have only 3 letters, which means if you take A, you don't have any A left. If you take B, you don't have. Later on in subsequent videos, you will see the difference because we will try to arrange the videos now in topics. So with permutation and combination, we are going to get like 5 videos with each one, maybe part 1, part 2, part 3, part 4, part 5, where we have the theory, we have solutions to different type of problems that you encounter in different examinations and also in your daily work life. So let's say I have 3 letters, A, B, and C. And the question is asked, how many ways can you arrange A, B, and C? So I will just look at this and say, I can start, I take the letter A, and then I put the other one, B and C. I can also have the letter A, and I swap the position of B and C, C, B. I can go to B and get A and C. So I take B and get A and C, and B, and I swap the position. I can do the same thing for C, C, A, B, C, B, A. So now the count is 1, 2, 3, 4, 5, 6. So there are 6 different ways we can arrange A, B, C. In a nice form, I'll give you a short way we can also think about it. So let's say there are 3 letters that I have to rearrange. We notice if I take A, then I rearrange A and B and C. So the first position can be occupied by A, B, or C. So there are 3 possible letters that can fill the first position. Of course, once you choose one of them, then you're left only with 2. So the next one, there are 2 possibilities, either the B or the C, and then 1. If you actually, this is 3 multiplied by 2, multiplied by 1, and that is 6. So, see, these also matches with that. Of course, you'll be asking, if we could just do this, why do we have to do this other path? I already indicated mathematics is intended to make your life easy, not difficult. So we have to make sure that when the thing starts getting complex, our mathematical idea should become simpler, or should give you an advantage compared to doing it this way. Let's say we go to 4 letters of the alphabet. Here they A, B, C, and D. Now there are 4. You should already start guessing that we need much more space. So first, what we normally do, you choose the letter A, and then you choose one other, and then you choose that. So this is one possibility. You can start again with A, and then you rearrange this. But we already learned here that when there are 3 of them, there are 6 possible ways you can arrange. So it means I can have 6 A's here. A will appear 6 times. 1, 2, 3, 4, 5, 6. Why this B and C change themselves into this form? So then I have 6 of them. If I do that with B, start with B and I do the others, then A, C, D, I'm going to have 6 of them as well. And if I do that with C, A, B, D, I'm going to have 6 of them as well. And then with D, 6 of them. Then if I have 6 plus 6 plus 6 plus 6, that is 24. Let's see if, you see, I'm already running the problem of space, of being able to write all this. But let's look at what I just showed here. Let's say now we have 4 of them, so we need 4 spaces here. So the first position you choose, there are 4 possible letters you can start with. You can start with A, B, C, or D. So there are 4. Of course, once you choose one letter, you are left only with 3 to choose from. And once you have chosen the second one, you are left with that. And 1. And that is 4 times 3 times 2 times 1. And that is 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. So that's 24. If I went to a 5th letter, you would of course see that you start now understanding why mathematics is good. Why it comes really to make our lives easy. In this case, we won't write them anymore. We will just try to borrow from what we've learned up to now. So I have 5 letters. If I have to do this, then I just draw, make 5 boxes to indicate the number of ways you can choose this of them. So this here there will be 5, 4, 3, 2, 1. And 5 times 4 times 3 times 2 times 1. That's such a 5 times 24, and that is 120. 5 times 4 is 20, and 2 over 10, 12. So it's 120. Imagine if we had to do all the possible combinations of this before we start counting, then I have to do 120 of them. I guess you start appreciating mathematics now. You start seeing the beauty of the math saloon, because that is what math is. In general then, we would say, if I had here a letter or 10 of these letters, then it's simply 10 times 9 times 8 times 7 times 6 times 5 and so forth, and you end at 1. Of course, it means if there were n of them, which means that I had A, B, C, D, so and so on. So with 10 letters, we are going to get 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This is what anyone can do. What you notice here is simply that you get the first number, you multiply by the number reduced by 1, and again the number reduced by 1, and so forth. So if I have n of them here, n letters to rearrange, then I'll get n multiplied by, I reduce the n by 1, I reduce the n by 2, you see? Yeah, n was reduced, my n was 10, it was reduced by 2. And by the end, you are going to get something like 3, 2, 1 as well, because it keeps on reducing until you reach 1 and you stop. This, the mathematician notice, is getting so long and complicated, and they don't want to bore your life with this thing. So we will just write this n multiplied by that. I will just write without a multiplication. You know, each of them is being multiplied. We just call it n, and we use this technique called n factorial. We call this a factorial notation, where n factorial actually means n multiplied by n minus 1 multiplied by n minus 2 and so forth. For example, 3 factorial means 3 multiplied by 3 reduced by 1 multiplied by 3 reduced by 2, and that is 6. 4 factorial means 4 multiplied by 3 multiplied by 2 multiplied by 1. We already saw that that's 24. And 5 factorial as well. We are going to move to our next video, where we now move into using the factorial notations to use them to define our permutations and combinations. See you shortly.